In this video, we're going to be adding a GFCI receptacle to the outside of a building. There's a couple of requirements that you have to keep in mind. Number one, any outdoor receptacle needs to be GFCI protected. So we have a GFCI receptacle that we're going to be using for that purpose. And then if you want it to be code compliant, it needs to have a while in use cover, which is this bubble style cover here that allows us to plug in an extension cord or whatever and be able to still close the cover. So those are the two requirements you got to keep in mind. So I'll link to a few different GFCI receptacle kits in the description of this video so you guys can check out the options. If you guys want to purchase this exact same kit that I have, I'll try to link that. Now, technically, we're not going to be mounting this directly on the side of a building. However, that will be the most common scenario. We are going to be adding it to the other side of this post right here. I already have power ran into this location, and we just have to drill through to the other side of the post and mount this on the outside, just the same as if this was mounted on the side of your house. So it's identical, except for we're doing it on a post instead of on the side of a building. A lot of the time you're going to tap off of an existing circuit for something like this, where we can just drill through the back of a receptacle box that's mounted on the exterior of the building to the outside and just add it right there. However, if you are going to run a new circuit for this particular receptacle, you will need your 20 amp breaker. I would recommend running 20 amps if you're going to run a dedicated circuit, and some 12 gauge wire to go from the breaker to the location where you're mounting your receptacle. For purposes of this video though, we're just going to be focusing on adding the receptacle, assuming that you're going to be tapping off of an existing circuit. If you do end up purchasing your GFCI receptacle separately, you do need to pay attention that it has the TR and WR markings on it, meaning that it is both tamper resistant and weather resistant, since this is going to be mounted outside. So inside of this box out here, I have this receptacle, as you can see. Now just imagine that this was a receptacle inside of your house on the wall. It's pretty much the exact same concept that we're going to be demonstrating. By drilling a hole through the back of this electrical box through to the outside, in this case it's the other side of the post, but it's the same concept. So let's go ahead and open this up. I've already disconnected power from this circuit, so we should be good to go. So we just need to tilt this out of the way enough so that we can access the back of this handy box here, and then we're just going to drill a hole through the back of the box to the other side of the post.
I want to take a few seconds to thank ThruNite for sponsoring today's video. They sent over the ThruNite T2 for us to take a look at. I've actually had this light for several months now, and it has been very, very handy to have. It's kind of a flood style light, so it's just good for general task lighting. It's not like it has a tight beam, so you can just kind of set it up and use it, which is kind of the way that I've ended up using it. It has a maximum output of 3,757 lumens, is rechargeable via USB Type-C, has a strobe mode, and you can cycle it through a bunch of different brightness settings to meet pretty much any situation. Has a deep carry pocket clip that you can slide on in both directions, which is very, very handy. It also comes with a holster and some extra O-rings to keep everything weather sealed. So if you guys are interested in this, I'll put a link right at the top of the description. I'll also link to this one. This is not what this video is about. The ThruNite TH30 headband light has been so nice. So I'll link to that one as well, even though technically we're talking about the T2 today. You can also get this in blue and desert tan. So check out that link, and let's get back to the video.
Perfect. Now the wire that we're using is a UF cable that's designed to be in damp environments, and that's what you're going to need if you're going to be running to the outside. So in this case we only need a couple feet. It's just enough that we can have it extend past the face of each box about 6 inches. So we're just going to go ahead and cut our piece of wire right now, and then we'll get our ends stripped back and prepared before we put this piece through. Right in the center of this cable is the bare copper wire, and that's what we're going to score next to. We're just going to use our utility knife for that. I've seen some guys take it once they get it scored through this first section here, and just take it and peel it like this, running your blade along that copper. Alright, so we have our through the wall piece of wire all prepared. Obviously, depending on what your project is, this might have to be significantly longer. We need to have at least 1/4 inch of this outer sheathing exposed inside each box on either side of the wall. Now I will be connecting these wires directly to the screws on the receptacles, so we're going to strip back about 3/4 of an inch right there.
That here is for you.
Oh man, wow, thank you. Did you give some to the girls, Ollie?
Yeah. There's a lot more.
Really?
There's a ton more.
You guys can eat all of them, it's fine.
I know we can, but I want to save them. I don't want to eat them all.
Wait,
Don't.
let me see you guys. Hi.
Hi.
What have you guys been up to?
I'll go
So,
check.
what do you have in your, do you have walnuts in your pocket, Ollie?
A wallet?
Walnuts?
I know.
Or are they pecans?
Have light. Have light.
Are you guys should finish eating all of them. Now in order to clamp the wire inside of this particular box, you need to use a cable clamp, and there's a few different styles that you could use. There's also some plastic push-in style ones that might be a little bit better, but this is a typical kind of metal one that you would see. And we're going to install it like this, and what we're going to have to do in order to make this work is actually drill out the hole over there where the wire comes through the post, and make a big enough opening there that this clamp can kind of sit back in there and still mount this tight up against the side of the post. Now the other option that you could consider is to put the clamp on the inside and thread it in like this. The problem with that in this case is that since we're putting in a GFCI receptacle, there's really not room for the depth of this clamp and the actual GFCI receptacle to be able to fit in that box at the same time. So we're going to have to use that clamp on the opposite side. Coming into this box right here in that hole, I'm not actually going to worry about getting a clamp in there, since this cable is clamped in the box right on the other side of this post, like 4 inches away. But I do want to ask you electricians out there, what would you guys do in this situation? Would you drill it out bigger to like a 1/2 inch knockout size and use a plastic cable clamp, or do you think it's fine to not put a clamp at all? It's still going to be anchored within, 6 inches of the box or 8 inches of the box, and so I think that this is probably totally fine. But comment right underneath this video and let me know what you guys would do. This 1 3/8 bit should do the trick for giving us enough space for our cable clamp behind our box. And I'm going to offset it just a little bit towards the bottom here. That should do the trick. There we have our cable securely clamped to the back of our box, and we can slide it through. And obviously normally you would have your wire just sticking out, and that would be totally workable as well. It's not a big deal either way whether or not you have the cable sticking out at first or not. For illustration purposes though, this works quite well. On the back of the box for this particular kit, there's a couple of little dimples. You just give those a whack, and that opens up these 2 screw holes so we can anchor this box in place. Otherwise, you can use these little feet that are included to mount it differently, but I prefer going straight through the back of the box whenever possible. Just go ahead and take your crescent hammer and give it a little whack. For the ground wire, we need to ground it to the box itself first, since this is a metal box. So I'm just going to wrap this wire around this ground screw. So our ground wire is in position. Now this is a very important detail, that you pay attention to the line and load terminals. You can see up here at the top it says line. That's going to be the power coming into our receptacle. And if we were to run something else downstream of this GFCI that you wanted to be protected by the GFCI, that's where we would use these load terminals down here. So our gold terminal on this side is going to go to our black wire, and our silver is going to go to our white. Now you can connect these in one of 2 ways. You can either wrap your wire directly around the screw, or you can push the wire into this back little hole right here and then clamp it down. And I think that's what we're going to do in this case. Typically I like to wrap it around the screw itself because it seems like that's a little bit better. But when we put this in here, we actually tighten this screw down and it clamps onto the wire still. So it's not the same as like a backstab connection where you push it in there and it's relying just on the little spring. If that's the case, I really wouldn't recommend that. It's better to use around the screw terminal. But in this case, it still is clamping onto the wire, so I'm fine with using that back connection like that. You can see with that, my wire is a little bit too long, too much stripped off of it, so I'll trim off there about 3/16 it looks like, so that comes closer to flush, just like that. Double check, yep, we're still on line. I did flip the receptacle over here, so in case you guys were concerned, we're still on the right track. Trim a tiny bit off of this as well. Get it good and snug, just like so. And finally, let's connect our ground connection here, and that's going to be right here on the bottom. Our ground wire is almost too short to connect it that way. I think I'm going to put a pigtail on there anyway because I am thinking to add a circuit off of this, so let's go ahead and add a pigtail to that ground connection. Hello, this is Ben.
Hey, Ben?
Yeah.
I just got a quick question for you. I was talking to your dad and stuff.
Sure.
And I'm installing a Nest thermostat.
Sure, okay.
Thanks, buddy.
Alright, no problem. Enjoy.
Bye.
See you, bye. So we're going to add a pigtail for this ground wire. It's still connected to the back of the box like we just did there a minute ago, but it's not quite long enough to reach out to the receptacle comfortably. Plus, I think I'm going to be adding a circuit coming down out of this box, and I'll need a grounding pigtail for that anyway. So we'll go ahead and get this connected. When you're connecting just two wires like this, in my opinion, it's not necessary to pre-twist them, but there is significant debate as to what the true correct thing to do is. I'll kind of match the existing wire length. So we've got our hot, our neutral on the other side here, and our ground wires all securely connected to our GFCI receptacle. So now we can carefully push our receptacle back into the box. Kind of a unique issue here. I don't know if this is just the exact one that I received, but this grounding screw right here is kind of interfering with the installation of the receptacle. So I'm going to have to take this back out and maybe just squeeze that little piece of metal down a little bit, or possibly grind it out, because this doesn't want to go in here with that ground screw there. See if that works a little bit better. Now that our screws are started, it's best to push the receptacle into the box by hand, and don't use the screws to squeeze it in there because you run the risk of pinching something super hard if you use the screws. So let's just push this in here and see if it feels good. And it looks like we corrected our issue right down here with that ground screw. So we are good to go. It doesn't feel like this is pushing strange anywhere, so it should be good. There we go. Up next, we're going to connect the wires inside of the box that's actually powering our receptacle, and we're going to just connect our wires directly to the receptacle in this case. So we're going to connect our white here and use these existing terminals to make our connection. However, oftentimes you'll see where there's some wire nuts in the back of the box where they use the pigtail method to connect the receptacle, and that's actually better in my opinion, but once in a while I'm fine with doing our connections directly to the receptacle. We will have to change one thing right here where this ground wire is, because we can't stack more than one wire, so we will have to disconnect that and add a grounding pigtail so that we can properly connect this. And we will give these ground wires a little bit of a pre-twist. One thing I want to mention really quick is if you open up your electrical box and you already had wires connected to both screws on either side of your receptacle, then you will have to take them off and add pigtails. The same way we added a pigtail for the ground wire, you have to add pigtails for both your neutral and your hot wires in order to allow you to make your connection. So just wanted to mention that, as that's pretty common that you'll have receptacles that have all of the terminals already used. Now we'll do the same thing where we carefully push this back into the box and make sure that nothing is pushing too hard anywhere before we actually connect it with the screws. Always make sure that your bare ground wire doesn't come in contact with the terminals on either side of the receptacle. Now that everything is assembled, we can go ahead and put our cover on, our newly installed GFCI receptacle. Alright, all that's left now is to give this thing a try. We're going to go turn the power back on and make sure that the test button works properly, and we should be good to go. Alright, the power has been restored. Let's press the reset button and see if it sticks. Haha! And test. Trips it right out. Reset. Good to go. Let's go ahead and plug something in. Whoa. Something's tripping out in there. Alright, let's take this cover off and see what's going on. That's not good. Oh boy. So you can see right there we have our ground wire touching the load side hot wire of our GFCI receptacle. So I'm going to carefully reach in there with my insulated screwdriver. You can see right now that it is tripped out also, so let's just go ahead and carefully reach in there and move that over. You can see that little burn mark. We'll push that thing back. Alright, we got that wire pushed away, so now we should be able to reset our receptacle, and it stayed on that time. So pretty funny and interesting that that exact scenario occurred right after I told you guys to watch out for it. So if I followed my own advice, we would have been fine. What was kind of interesting about the way that happened was the receptacle reset at first and it was fine, and then when I let the cover slam closed, that's when it tripped out and I saw a tiny flash. Alright, now let me grab an extension cord and we'll test this thing out. Here we go. Go ahead and plug it in. And now, in theory, you'd be able to close this while the cord is plugged in. Alright, let's go check out to the other end of the cord, see if the lights are working. There we go. It is working. So the next phase of the project is going to be running power underground. You can see I've already got the trench dug and the wire is in place for that project. So if you guys want to see how you run a single circuit to an exterior building, make sure that you subscribe and hit that bell to turn on notifications. As always, all the parts and supplies for this project will be in the description. That concludes how you add an exterior GFCI protected while in use receptacle. If you want to keep learning with me, I'll put a couple videos right here on the screen. So I'll see you over there in just a few seconds.